Hi, I'm Physics 101, along with my good friend Skip. We built a 1970 style pinball machine from scratch. Now what I'd like to do is kind of give you an overview of the kinds of things that you're going to run into when you build a pinball machine. We're going to try to provide some details of some of the things you'll run into, as well as some of the more general facts that maybe you don't know when building a project this size. I also have another video on here you might want to see. It's called a kinetic energy sculpture like Iron Man 2. And if you want to do that project, it's a lot simpler than this one. It's a lot of fun. Okay, getting back to the pinball. The first thing I think we should think about is a working title or theme. Now mine was Meteor, so it was pretty obvious for me. I wanted to do something that was real flashy, noisy, all that kind of crazy stuff. And I want it to be good for my grandchildren as well as for adults. So Meteor is what was my theme. Now this was not the way it was started out, but this is the way it ended up. So with that theme I started conjuring up all the kinds of things that I wanted to incorporate into the playfield. And this is where you start. So I was thinking about the colors, the graphics, the sounds, the components. See, all those kinds of things and how they'd be laid out to kind of emphasize that Meteor concept. So as I started doing that and thinking about that, I laying things out. I went to the internet, looked at a lot of different kinds of designs and stuff. And when I finally kind of got some ideas, I put it down on paper. And that's what I want you to do. I want you to do a half-scale drawing to scale. And that's a 20¼ inch by 42 is full scale, so do half of that. It's a lot easier to do a half-scale drawing. And then lay it all out on a piece of paper. Now I have my first drawing here. Now it probably won't come out that well for you on video, and I'll show a photo on there too, but I'll hold it up anyhow for you. And you can see that's my very first drawing there. And you can see the flippers and the pop bumpers and the tunnels and the rollover wires and all the various components that I saw they ought to look like. Alright, so that's my first drawing. Now once you do that, I want you to sit on it for just a little while. And once you do that, you may change your mind on a few things, or rearrange things. You may see something else you like on the internet that you might want to incorporate in that. And that's cool. That's when you want to do it. It's a lot easier to do it now than it is later on. You know, this is the time to kind of make those initial changes to what that playfield is going to look like. So once you've got that and you're happy with that design, then I want you to go full scale, and I want you to put on a vellum. Now vellum, all vellum is the kind of material that draftsmen and architects use to do full scale drawings, very critical drawings to scale. And that's what I want you to do. But inside a 1/16 of an inch, you need to make this very accurate drawing. Now this is a full scale drawing, and I'll hold it up, but I doubt that the lights will allow you to see it very well. But you can kind of get an idea of all the intricate measurements that you're going to make in order to get a full scale drawing. There are over 200 changes on this. This is actually my final drawing after working on the whitewood for over 8 months. And this is what you're going to end up with after 8 months worth of work. And this is your pot of gold. You want to make those changes as you work on your whitewood, so that when you're finished with getting that totally operational, then all you have to do is transfer this information to your final playfield, and you're ready to go. And there's not going to be hardly anything you're going to have to make changes on. You might have to make a few small adjustments. So this is your goal. All right. So you want to go to full scale here and get all of those measurements accurately put on here exactly the way you want them. Now this won't be totally right. You're going to find things you don't like or don't work, and you're going to have to change them. So the whitewood is what I already mentioned, is the actual work playfield. That's what they call the whitewood. And all that is an exact copy of the final playfield that you're going to use. And that's the one you're going to work on. You're going to paint it white. You're going to put all your drawings on there and make accurate measurements. And you're going to And then you're going to route all these holes. You're going to cut all the slots. You're going to put every imaginable hole in here. And there may be as many 300 holes that you will have to drill with a Forstner bits or a plunge router in order to get all these holes in place. And take your time, because you want to do some practice work and get it really accurate so that when you do your final play field, you won't be making any mistakes. So that's a key thing to do. Now some of the tools, and I mentioned one already, your plunge router. You can get a plunge router, if you don't have one, at Home Depot for around 110 bucks. And it works quite well, as you can see from this. I used that on this. The key though was to get very good router bits. Don't buy cheap bits for this. You don't need that many bits to do a project like this, but you do need really quality bits so you get very precise, clean cuts. Because a lot of the cheaper bits don't last very long, and pretty soon you're getting chips and all kinds of things that drive you nuts. Okay, so the plunge router is real important. Also, an automatic wire stripper. You can't do this project without one. I can tell you do thousands of wire strips, and you're using very fine wire for the most part and in tight places, and you need precise stripping. And I'll show you some things that we'll be doing to cut down on the wiring. It'll be kind of cool to do and make it a lot easier to get this thing wired up. But you need one of those. You also need a power drill, because there are going to be some places where you cannot get into with your router, and you're going to want to make some changes, and that'll allow you to do that using a jig, and I'll show you how to do that too. Another thing you'll need is a digital multimeter, and they're not very expensive. I got mine from free from Harbor Freight, and I'll show you the one that I got. But you'll have to buy those little attachments so you can grab a hold of very small resistors and capacitors and diodes and that kind of thing, and test them. And one of the things that Skip emphasized a lot to me, and he's my mentor on this stuff, is that you test everything prior to installing it to make sure it's what it says it is. Then you test it after you install it to see if it's still working, or in combination it's the right ohms or whatever you're trying to accomplish there. And third, you test everything just before you power everything up on that circuit board. It's a very important process. Okay, another very important thing you're going to need is a variable temperature soldering iron. Mine is a Heiko, and I really like it. I've used it for many Tiffany lamps. I just put a different point on it, and I really like them because they're ceramic, and they heat up very quickly, and there's no cold spots. And that's kind of important when you're working with real intricate soldering. And also that you can also change the temperatures for soldering larger components, and then do the real intricate soldering with the lower temperatures. Very important to have one of those. Okay, some of the supplies that you're going to need: 3/32 shrink wrap. I used almost 150 feet of that. It gives you an indication of how many soldering joints you're going to be making. Just an enormous amount of them. Also, you'll need 22 and 24 gauge stranded wire. I bought 3 reels of that stuff on the internet for under 50 bucks, and they're over 1,000 feet each. So you can find really good buys on the internet. Just kind of shop around and find the best buys. You're also going to use 22 gauge for your higher voltage, larger components. So you got basically 2 different kinds. And then you'll use some 16 gauge for your inlines to your startup of your machine, but not much of that. You'll use some hot glue, so you need a hot glue gun for your temporary insertion of your inserts and some things, so you can take them out and change them around, switch them around. You might not like the color combination, stuff like that. You'll need solderless connectors. I used over 300 of them in the 2 play fields, because we're going to have a lot of terminals where you're going to be using solderless connections. You can disconnect those connections quickly and then reconnect them when you're trying to test something. You don't want the high voltage on there when you're testing them at low voltage. So there's a lot of that that's going on. You also need the other kind of connectors from your circuit boards to your various components. We might have a 9-pin or even up to a 25-pin. I use a 25-pin on my scoring reels. Okay, see other things you'll need. You need fine solder. Make sure you get a very good quality solder for this, because you don't want to be going back and trying to find out what was a bad soldering connection, because it takes forever trying to find it, because you got lots of various circuit boards. We had over 11 of them in this. We did 11 separate circuit boards, one for each component. It was so much easier to design and program them, and also work on them. If you wanted to change them, you only had to work on one little circuit board rather than the whole thing. So I advise you to do it that way, and I'll show you what we did. Let's see, what else do you need? Of course, you're going to need diodes. You're going to need, I use a lot of little glass diodes, but I used other ones too. You're going to use a lot of resistors, some capacitors to cut out interference. What I will tell you to do is buy in bulk. Even if you buy like 1,000 of them for like 15 bucks and you only use 20% of them, it's a lot cheaper than buying, individually resistors. We use an awful lot of resistors. And we reduced our resistor usage by using some power supplies for LEDs, so we didn't need resistors. Okay, you're going to do a lot of the fabrication, I can tell you that. You're going to make your cabinet, you're going to make your back glass, you're going to do your painting, or you can do it in Photoshop. You're going to do all of your plastics, you're going to do your shooter grooves, you're going to do a lot of the carvings that you'll need. I'll show you some of those in the next short video, things you will need to do in order to accomplish what you're trying to accomplish. You'll find there's some information available on the internet of how to repair things, where you can get an idea of how to insert, say, a flipper button into the cabinet, because they'll show pictures of that, but they won't actually tell you how to do it. You just have to figure it out yourself. It's not that complicated. I'm just saying there's not a lot of information out there. So you're going to, and also the sound system, which is kind of cool. You can set that up yourself. I'll talk a little bit more about that more specifically, but this, I've got a nice sound system. It's very, very, very clear, stereo, and very simple to use. And I'll also spend a little bit of time on some of the jigs I made up to do certain things, like how to make the shooter groove. Seems complicated until you see how I made the jig, and also how do you install the legs properly on the cabinet. I used a little jig for that, and just simple little jigs like that to help the process a little bit, make it a little easier for you. And lastly, I wanted to say to you is this whole project is a trial and error effort on your part. Since there is no specific drawings or dimensions for anything other than the actual size of the play fields, and maybe you can say, like I can tell you that the standard shooter groove is 15 3/4 inches, but other than that it doesn't really tell you much. But I'll be a little more specific on that. So it's all trial and error. Don't be discouraged if things don't work right. You can fill in the holes with little wood dowel and glue, tap it in there and cut it off, lightly sand it, and go ahead and move that hole to a different place and try that new position. It's a lot of trial and error, but it's a lot of fun, and when you get done you get a really neat, cool machine like this. Oh, I want to mention one other thing is we did use a bunch of chips in here, and I'll talk a little more specifically what those chips are and how we install them on our breadboards in a subsequent video. Okay, this next short videos, and we're going to talk a little bit about the workstation, because this is going to help you a little bit on how to set up your whitewood and then work on it. Now, I'll show you this part first. This is a very simple A-frame. There's two A-frames put together with two long stringers, a little bit longer in your play field. You want to allow a little room for your 1/4-inch piece of plywood that makes your disc here. Then also you're going to need some angle iron that you can get at Home Depot. You want to cut these down. You don't need them really thick, just sturdy. And make your supports on the sides. And you notice there's holes here that you can attach the whitewood to. Now the disc is going to be, and I'll show you how that works. The disc is going to help with your different angles that you're going to go to. Okay, now the whitewood, which we talked a little bit about, but we didn't really show it to you. The whitewood is a piece of 1/2-inch plywood, the exact size of your final play field. And this is where you're going to do all your work. And what I want you to do is it's 1/2 inch wide. It's 20 1/4 inch by 42 inches. That's a standard size for a play field. And I suggest this is the size that you use. Now, what I want you to do is I want you to make sure it's exactly square and exactly the right dimensions inside a 1/16 of an inch. It has to be very, very accurate. Once you do that, then I want you to paint it with an acrylic white flat paint. Lightly sand it by hand. Don't use an electric sander. And get all the dust off and paint it one more time. And you'll notice that you get a nice smooth finish and all the grain's gone. Then you can put all your drawings on it from your vellum, and that's what you want to do very accurately. Once you do that, you now have a work surface. Now, the way you can, and I'll show you this once I put this on here. Now I'm going to put this on and show you just how it fits on here. And you can see that I've got it to where I can slide it under that little bolt there. And I can do that on this side too. Now you might have noticed that there's some little holes at the very top. And I have some bolts here, so I'll put a couple in just to kind of show you how this works. I'll put a bolt here, like this. But you want to put 4 on, one in every corner, because this particular play field will start getting heavier and heavier as you add more and more stuff to it. So you want to try to ensure that you have a nice, secure board. Now I'm just going to stick these on here temporary. You want to put them on there fairly tight so they don't move at all. But we don't have anything on it right now. Okay, so now we have it on there. So now that you have it on here and you've drilled all your holes before you put this on here, you've got all your holes. Now we'll talk a little bit about that. Now you've got to be able to work on this. And right now it just moves around. Well, that's what the disc is for. When you get this on a very level, use a little level and put it on there. When you get it nice and level, what I want you to do is I want you to clamp this down, and I want you to drill a hole through the A-frame below the play field, through the disc. And when you do that, once you do that, then you can take a dowel, and you can take that dowel and put that dowel through that hole, and now you have a nice sturdy position to work on. So you can be working on something up here and maybe shooting a ball up here and checking, get the angle right and everything, 6.5 degree angle so that you can see how the ball goes down, all that kind of thing. Then next thing I want you to do is I want you to turn this thing this way, drill another hole through it, and through the same hole that you already drilled through the disc again, and now you can work on some things this way that would have been way over there. You see what I mean? And then lastly, of course, what I want you to do is I want you to turn it all the way over and then drill another hole through here, through the disc, and now you stabilize it that way. So now you have your 3 positions. You can see, even though we're at not much of an angle here, there's literally 300 plus holes in here. A lot of mounting holes on the underside. So this is something that you have to have in order to do this. And on the bottom side you have your terminals up here, okay, where the wires will come off like this, and maybe you'll have, like I used, some rubber bands to hold your loose wires coming up. And you see these shelves over here. These shelves I built to hold my power supplies. so that when I powered something up, I could flip this back over now to this side, and I could shoot a ball up through here, around through, and watch it bounce along and see how it worked. And if it didn't work the way I wanted to, then I'd have to change something. So that's one of the things that I want you to realize that you need to do. Now, one of the things that I didn't mention yet is that these inserts that go in here in a lot of these slots, they're cut with a router. That's the best way to do it. They don't go all the way through. They go down the thickness of the insert, and the inserts are roughly a 1/4 inch. Okay, so that means you're going halfway through that play field. Then you'll drill another hole, a smaller hole through there, and that's where your LED will come up and light up that insert. So, and then what I suggest you to do is just a little dab of hot glue, and you stick that in there, and it'll stay in there. Then later on you say, you know, I'd rather have that one over here. I like that blue over there. And you're working on your color combinations, you know, for your final play field. You can take them out, and you can also still use them in your final one if you wanted to. But don't glue these in for real, because then you'll end up having to use all brand new ones, and you don't really need to do that. You can take these out and use them in your final play field. Okay, so that's important to make sure you get these in there flush. On your final play field, they won't be flush. They'll be slightly proud, so you can glue them with epoxy, and once they've dried, you're going to hand sand them so they're perfectly flush with the play field, because nothing's perfect unless you do it by hand sanding it. And don't worry about them getting dull with your 200, 300 sandpaper that you're going to use. After you put the clear coat on, they'll get shiny again. Okay, now some of the things you're going to run into, and I wanted to show you this. Now, my play field, one of the things I wanted was this gate with the tunnel that went around and back down into the play field. And I saw this and I said, you know, a photograph of it, and I'm saying, boy, I really like that. I'd like to do that. But this is what you see. Now I'm going to angle this up a little bit so you can see what I'm talking about. I'll put a stick in here. Okay, so this is what you see when you see the photograph. You say, okay, I see this arch here, and I see an arch running around this way, and that appears to be stainless steel, and that's stainless steel going around there, and you would be right. So that arch follows this arch going around on the top of the play field, and this is the arch going through the gate and coming back to the tunnel. But you can't really see much, and the reason why, and you'll see this in a lot of the photographs that you view, is because the plastics are hiding it. And the plastics are to hide things they don't want you really to see because they're not that cool. Not because they don't want you to know what they look like, you know. But so they put lights underneath it, which you'll do, and you'll put graphics on it, see? So I'm going to take this plastic off so you can get an idea of what's underneath that, just to get an idea of what you're going to run into and how you're going to figure out how to do it for your own particular design. So, okay. So this is we'll talk about that later. So now you can see this piece of wood is carved out of a piece of poplar. That's what I suggest you use, is poplar. And we'll take these posts out so you can see this thing. If I can get them out here. Okay, get these posts out. Posts should fit in pretty tight. You don't want a lot of play in them because they're going to take a lot of beating over the years. And these are the metal posts that hold the plastics in place. So now you can see this piece of poplar that you can buy at Home Depot by the board foot. You can get, you know, and I made the arch out of that too. I made about 4 or 5 carvings. That's what I refer to as the carvings. So you're going to make this, and you notice now that I hold this up, it's not a perfect circle. I found out later that I needed to make this a soft curve here, so it comes in softly, and then it starts curving harder and harder as it turns around to go down through this lane and back down into the play field. So I lined this with stainless, and I lined this with stainless. But you notice on this side, over here, they had to protect this corner here, and this side with rubber. This is a rubber. So they put a post here, and a post here, and you'll see a lot of little elongated triangles. Now this allows the ball to come off and hit this way and bounce out back and down through one of these lanes I have up here. You could have anywhere from 2 to 6 lanes up here, depending on how you want to design your play field. Now this is straight here because I have a lane running down here that I want that to bounce along and then go through that lane back into the playfield. Okay, so that's the reason for that. Now let me stick another post back in here so I can show you something else if I can get it back in there. Okay, now you notice down here there's a post here and a post here. Now you could see that initially. The reason why they do that, and this is kind of important, I want to stress this to you. There's a little rubber on there. What that's doing is two things. It's preventing this pinball from hitting metal directly on. You don't want that to happen. So if it hits here, it'll bounce away at some crazy angle. That's cool. That's what you want. You do not want to damage this ball. As soon as you see a damaged ball, you need to take it out and replace it, because any chips in this will start eating up your playfield, and that's kind of critical. So, you know, that's why they do that. So that's the reason for the plastics over. It hides all that, and you also get this really nice, if you can see that on there, really nice graphics on it. And mine are creators because I'm doing, you know, meteor. So that's how these all look. Now I got another example one with the stainless steel still on it. Now this is pieces I cut out of stainless, and then I polish them up. You can polish them, get them real shiny like this. And you see how it fits on there because I crimped it on either side. And that piece is going to fit right there. And I'll have a target there and a target there. And then what I'll do is I'll put a post in the center, and then I'll put a post over here, and then I'll put one more post, I don't think I have one here, another post right here. And what that does is keep the stainless steel, oh not stainless, but chrome ball from hitting the side of that target and breaking it. It's got to hit it from the front. If it doesn't, it'll just bounce it off. And also, you know, that's the reason why you have those three posts in there. And of course the plastic itself, I'll show you what that plastic looks like. Here's that one. That one would fit right there. And then you would have lights underneath it, LED lights to light it up. Really cool. Whatever you want. You can have flashing ones, you can have strobes, whatever you want to do. Now this is made out of Lexan. Now let me tell you how that's done. I'll show you a couple here so that you can see. Now this is how you make a template. You get some really cheap thin plastic like this because it's really easy to cut. Okay? That's what you want to start off with. Now this one actually fits over here for the other side of this tunnel. Now there's 6 holes in here that you got to get exactly right so that they fit over your posts. And then you'll use this, you know, and you'll have a wood carving just like this that'll sit on top of. Okay? You can paint it white or silver, anything to reflect the light back. Once you make it out of this, then you want to cut it out of Lexan. And you can get that at Home Depot too. Now Lexan looks like this. It's very, very tough. You can see you can bend it as hard as you want and it'll come right back to the original shape. Very tough material, very nice to work with, although it's a lot harder to cut than this plastic. So you make it out of this first and then this. Alright, so once you, let me see if I got the water slide paper, yes. Here's the water slide paper. This is kind of cool stuff. Can you see the craters on there? That's my theme. So if you, this will actually end up like that on there, see, on the bottom side. But you actually cut it the opposite way because the glue is on this side. And the instructions are all in the water slide paper that you use to do this with. Water slide paper is the right way to go. And to do all your graphics. You can do your numbers that way, your lettering, all the rings around, your inserts. It's really cool stuff to use. I think the kind I use Papilio, something like that. Anyhow, good stuff, very easy to use. Just practice a little bit before you actually do it, you know, small pieces of it. And so you put it on this, and then you end up with one of these. Now, you notice it's nice and shiny on the top, and then on the bottom, that's one, because I told you put it on the bottom, and since it's on the bottom, it has a clear backing on it. You can't really see the color very well. So what you have to do while you still got this front covered by something, either left the, you know, you've got to put tape on it or whatever to keep it protected. You want to spray a light coat of white on it, flat white, very light coat. You see this very, very light. And then when it dries, put a clear coat over it, and then you end up getting a really nice looking plastic. So that's how you make your plastics. Okay? So this is how this is your workstation. This is how you're going to be working for over a year probably. because you remember you're going to do your whitewood on here, and when you get it all working, and then you're going to start working on your breadboards and your circuits to complicate it more. Put in all kinds of variable timers in it, and for you to kick out holes if you're using them, or whatever kinds of things you want to do, strobe lights and sounds and all that. That's all going to be done by your circuit boards. That's after you get it working. But as soon as you get everything working, before you get to the electronics, go ahead and make your other board, because you've done it already. You've done that part. You know, that's 80% of it. So go ahead and take that vellum that you're making changes in this whole time, draw it out on your other board. And by the way, I want to mention this to you. Use one of these for all your lines. You see, you can put this on here, and it's perfectly square. And so you can line up all your holes and make sure they're perfectly all in a line this way, and you can turn around the other way and do it the other way. I had boxes of lines crossing all over on this thing. You can erase them later. But that way you can line everything up with one of these drafting squares. These are really cool to have. They don't cost that much. It makes it a lot easier for you. Then you take all of that and drill all those holes and then you want to do all your graphics on it, and you want to clear coat it and let it sit for a minimum of 3 months before you do anything with it. So while that's curing and hardening up, you can go ahead and finish out all your electronics on here. Okay, so that's the best way to approach this. Now, okay, let's talk about some of the tools that you're going to need. The first one I think that I should talk about is a digital multimeter. These are fairly inexpensive. I mean, I got this one free from Harbor Freight, but they're about $7 to $10. But you're going to have to pay a little extra cash, because I would like you to get this kind of connection. You can see that it has this little piece on the end that grabs onto wires, and you squeeze it like that and grabs the wire. I'd like you to get those, because you can grab those right onto a resistor or capacitor, and you can test things right away. The next thing that you're going to need, and you can't get away without one of these, there are different kinds. This is an idea, but it's automatic wire stripper. You've got to have one of these. Now this one goes from 16 to 26, and we use primarily 22 and 24 gauge wire, but we did use some larger gauge. This is imperative. You do 1,000 strippings easily. Now another thing that I think really is helpful is you see it's kind of a curved clipping tool, cutting wire clippers. Very simple, spring loaded, and they get into tight places. You need one of those, because you're going to get into very tight places to cut wires and make sure that nothing shorts out. Another thing, this kind of antiquated one, but anyone will do, you'll need a crimping tool like this to crimp your solderless connections. We talked about that before. And of course, I wanted to talk about the variable temperature soldering iron. Now this is a Heiko, and I really like this one because it has variable temperatures, and it's also ceramic, so it has no cold spots, and it heats up in about 8 or 10 seconds. So you'll kind of like it because of that. It has you can put different kinds of tips on. This has a very fine tip. And also make sure that you get a nice stand. Another thing you'll need on supplies, you need nice fine solder like this, rosin core solder, and that's what we primarily used. Now, some of the other supplies that you will need are, and I bought it this way, this 3/32 shrink wrap is terrific. You buy it in reels of 50 or 100. I use 150 feet of this stuff. Now another thing that you're going to need is 24 gauge stranded wire. This is 24 gauge. I got 1,000 feet of this on 3 different reels a piece, and it's for 3,000 feet for under $40. And then you also need 22 gauge, looks like this. I got red and black for my heavier gauge stuff, and you'll need that. Now, one of the other tools I should mention to you that you'll use for your breadboards is this tool. If you're familiar with it, then I don't need to really explain it, but basically it's the tool that you use to attach your wires to your supports that are underneath the breadboard. And then of course this is the very fine wire that we're going to use underneath our breadboards. And of course it helps to have some tweezers, and this solder wick works really nice. And one thing that I will mention up front here that you'll want to use on your whitewood initially to power up your large components, you notice this is a solid state relay, and this is the one that we used. I used about 20 of these things. They're about $50 a piece, but you can get them out of China for around $7.50, $8. You just have to wait 3 weeks for them to get there, but that's worth it. Alright, on this short video, what I want to do is I want to take you through the process of making a plastic. It's kind of a relatively simple process, but it helps to have a little instruction on it. The first thing you want to do is you want to work off the component that you want to cover in such a way to make it look cool. And the way you do that, like for instance, this is my carving here, plus there'll be some posts and things that I want to mount on, and there'll be rubbers going around. What you do is you take a piece of plastic, very thin, cheap piece of plastic like this, and you cut it larger than the component that you want to cover, so that you now can place this over, like this, over the area that you're trying to cover. Now on this side, see, you won't go over much, but over here you go more because you're going to have rubbers here and posts sticking out here, so you want to cover those areas. So that's the way you do it. And then you can see that, I'll hold this up, you can see that I put dots where all those posts are. And that's where you first start. Okay? So now you drill those holes. And then after you, and drill them a little larger than the posts. And you know your posts are pretty small. And drill them a little bit larger, you can have a little bit of movement in. You don't want them super tight. Then you put it back on the piece that you're trying to cover. Alright? And then you're going to trace with you know, not a ballpoint pen, but a felt marker. You want to, or a Sharpie. You want to trace an outline of the pattern that you're trying to create on this plastic. And what you want to do is look straight up on top of the component that you're covering, and try to split the rubber on either side right down the middle. That way you'll have half the rubber exposed and half the rubber underneath the plastic. That's the coolest way to make them look. That's the way they do it. Okay, once you've done that and you've got this nice and smooth and you're happy with that design, then you want to transfer that by putting that on top of a piece of Lexan or plexiglass like this. This is the way it comes in sheets. And you'll cut out a piece and you'll leave that covering on it. Don't take it off like I have here. You'll leave it on, and you'll now trace it and then cut it out. Drill your holes first, and then cut it all out and get it to match your template exactly. Once you've done that, you go and check it just to make sure everything is cool. If you need to do a little fine adjustments, go ahead and do that. Now we have the plastic, and we're going to take the bottom cover off, leaving the top cover on. And the reason why, you're going to put the graphics that we're going to use on the bottom. Now the way you do your graphics, and I'll show you how I picked this design for the graphics to go on this. So you can kind of get an idea what it would look like. So I wanted craters on there because the name of my pinball is Crater. Right, but it's too light. I wanted it darker than that. So then I came up and I finally got this color. Now this is on photographic paper. Now when I printed that up on the paper that I'm going to use, which is this water slide paper, you find it printed much lighter. So what I'm telling you to do is print very small 2x3 squares, you know, rectangles, and just keep printing them. And you can see I did all different kinds, and I finally got a couple that were very similar to what I wanted. See? And so now I have the color. I kept track of which ones were which, and now I know that if I print it up, it will come out right in Photoshop. So that's what you do. Okay, we're going to go do a little close-up because we want to cover for this carving. So we've already got this transferred to our Lexan. Here's our Lexan. And we're going to put it on the underside, remember. I've already taken the plastic coating off. So what we do is we take our water slide paper and we put it into the warm water like this. Hold it down, and over time it will start loosening up. Start moving it around, it'll start moving around. And you can feel it. It usually takes a little time for it to start loosening up. See, it's already starting to loosen up. Okay, so now we got it. It may take a little longer, a little less, but see how it's sliding around on that paper. So then what we want to do is, remember we're putting it on the underside, and here we are, going to slide it right onto that piece of Lexan. Line it up really nicely. Then what we want to do is we want to smooth that out very smoothly using a really nice soft squeegee like this, and get all those bubbles off. Once you get all those bubbles off, and get all those lines completely out, we get it on there really nice and straight. You can see it's really done already. So now when you look at it from the other side, you can see it's almost transparent. And that's that's not what you want, but that's what you want for this first stage. So you're going to let this dry, even though it's very transparent now, and that's okay. You are able to control the color by what we're going to do next. So the next thing you want to do is you want to spray the back of it, of this particular piece that you're doing, with a flat white acrylic. Let it dry. Very lightly coat it so you can just almost see the color coming through. And then spray a light coat of urethane or polyurethane on top of that. And once you do that, now you can see that the color has really popped. That's the same one that we've done right here. It doesn't really show yet because we don't have the white behind it. And now that we got the white behind it and we've controlled the color, you can see all the nice detail of the craters in here, which is the theme for my particular pinball machine. And here's another example of another one that I did for another plastic. So you can see you get all kinds of varieties of colors. Remember, when you do this is to do a reverse printing so that it comes out the way you want it, because you're doing it on the bottom side. Okay, a couple interesting things. This is a ball return from the early 1970s. You can see that it's a very simple design and a ramp that goes right up and then down into the shooter lane. And then you can see the shooter groove there. Then you can see right in the center, if I get the glare off of it, you can see the ball saver. Then we move up a little bit, you can see how I mounted the strobe lights, which are all they are is very high powered LEDs. Okay, here I wanted to show you how these wood pieces are carved, and you can see as I move down that there's stainless steel running around the edges of that, And then even on this side, which is another carving that goes from here all the way down to the spinner, that's stainless steel, and there's a wood carving under that. See, you can see the lights underneath it. And then if I move over to the other side, you can see another carving with a nice arch in there, and it's not a circle. It just starts kind of tame and then curves sharply as it moves around, and that's stainless steel too. And you notice then on the other side that I've glued stainless steel to the other side. So, and then of course I've got LED lights mounted in there, and you can see how I mounted those. And then the same thing on the other side. So, and then of course, here's a thing of notice that you might want to do when you do your arch. You see how I cut a little notch in the rail? That way the ball, when the ball comes, if it happens to hit it, it won't hit the stainless steel. It curves all the way around to this metal gate, and then it goes all the way around to this other gate on this side. Okay, another thing that you can add to give a little flavor to your play field, you can light up your post. If you notice, these posts are lit up with LEDs. And I can move over here to any of the other posts. Here's the ones by the spinners. You can see they're lit up too. And what I did is I shaved down LEDs so they were thin enough to fit in between the plastic and the post. And as you go around, you can see that it really gives a nice look to the playfield. Then you see this really bright area here on the side. And that's basically what I did there is I put programmable LEDs on the side rails so that they change color all the time and drive you a little nuts. But the overall effect, when I pull away from it, you can see how nice that looks. Okay, an important thing that you have over here, you can see that you got a shooter gauge there, and I got a used one off the internet and just painted it like I wanted it. And then if I move up, you can see the shooter groove, and it moves up and eventually just disappears. Alright, what I want to show you now is how to make a very simple jig to do the shooter groove. And when you first look at it, you say, well, how the heck do you do that? But it's really not that hard. What I want you to do is you get a nice piece of stiff, very straight. Can't have any bows in it at all. It's got to be very straight across here. So be very selective of the piece that you use. If it has any bow in it, it won't work. And I want you to cut a slot in it. It doesn't have to be this wide. It just has to be wide enough for the bit. And the bit that you're going to use in it is a rounded bit. So that it actually makes a round groove in the bottom of the wood. So what you're going to do is you're going to cut a slot like this in here. Wider on one side than the other. And then on the bottom, you're going to put a 1/4 inch piece of plywood. That's critical that it's 1/4 inch, okay? And then glue that to the bottom. So now when this lays down on a piece of wood that you want to put the groove on, okay, I've got a sample piece I'm going to put in here to fit in here. I think it will. Okay, so now what I want to do is I'm going to clamp this down in both places on this side, centering it in the area that I want to make my shooter groove on the whitewood. And then I take my router. Your router has a nice guide on it. So all you do is take your router and very carefully, starting here on the guide, you work your way up that ramp with that bit. When you get all the way up to the end and off the top, don't cut the end off. But as soon as you get a little bit past, then you know you've actually gone past the 0 point. And when you take your jig off, it has a little guide on it, you'll notice that you'll end up with a very nice, oops, got backwards here, you'll notice that you've got a really nice groove that starts at a 1/4 inch deep. Remember, you're only working 1/2 inch plywood, and by the time you get up to the top where you've got that 1/4 inch piece of wood, it'll lift up high enough they'll come right off the end, and you end up with no groove at the other end. And that's the groove that will be in the lane for your shooter lane. And you need that to put that pinball on. So when the plunger hits it, it goes right up that lane in a nice straight line. See how nice and smooth that rolls? And I would suggest you do like I did here, that you practice this a number of times so you get a nice even groove. You can see how nice and even this is. You practice it a number of times before you actually do it even on your whitewood. And then I would say, and the real key to that is that you need to really make sure this is centered here and at the bottom. In other words, you want to put like a ruler across there, make sure that it's exactly centered here and up at the top. And once you do that, that groove will be right in the center of your shooter lane. And it's almost impossible to screw it up unless you jiggle it. And then you'll, of course, get a wave in and it won't be any good. But that's how you do it. Okay, another little simple, very simple jig to make. But the way I want to tell you how to use it, if you notice, I use hardwood like a red oak, something very hard. And I take my drill press and I drill different size holes in here depending on what I need them for drilling in the playfield. And this is primarily to use in your whitewood, because when you do your final playfield, you do it all using a plunge router. You won't have to worry about getting your hole straight up and down, which is very critical. But if you're practicing and you've got a hole in the wrong place and you want to take everything off, what you can do is drill a hole like this in your drill press. Then you can put your drill through that with your power drill and drill that hole in the new position that you want to put it in. And you want to drill them kind of in the corners so you can get them into the place you want to put the hole. Also, you want to have more than one of them, so after they start getting wobbly a little bit, you can rotate to the next one. So I have a number of these for different size of holes. So if you say, well, I want to replace that 1/8 inch hole there, you have an 1/8 inch hole here, you can go over there and put it right in the corner there. Make sure you got it exactly where you want it and just drill it right straight through. Now it might split the wood a little bit underneath, which won't happen with your plunge route. It doesn't matter though, because it's just your practice playfield. And this is a real simple way of making a really simple jig to save a lot of time. So here we are looking at a breadboard that has a few things on it already. As you can see, we've got a chip holder here and I've got a few resistors on here. Now what I want to show you is the holders that you have, and these are made by Vector, and what they are is they're little metal holders so you can attach your components, and I'll show you what one looks like. You see, it looks like a little yoke, and what you do is you put it based on your schematic, whatever position you want it in, and then you get it in the right position, square it up, rock it a little bit, get it in place like that. And once you do that, then all you have to do is take a piece of solder and touch the base of it like this. And there you go. And now it's ready for an installation. So here we are going to put I'll put this in the front so you can see it. Here's a diode that we want to attach on here. So we've already put those in position. So all I have to do now is solder that diode to that yoke. That happens sometimes. It does move on you because they are very light. But you want to get this right on the top of it. There you are. You're done. So now it's on there nice and tight. And of course you want to do the other side too. And once you flip it over, you'll notice that I already have a wire on here.
Now I'm going to show you the other part now. This is the tool we're going to use to attach this. This is what it looks like. If you look at this end over here, see a little notch there, but on this end you'll see there are two holes on the very end up here. Alright, and I'll show you how that works. Now you take the wire stripper that comes with it and you put your thumb on there, hold it, and you pull it like that and it strips that wire. See how that wire is nice and stripped now? And then you take this tool, if you do it right, it slides right up into that slot there. See how it did that? And you bend it over. Then we're going to attach it to where we want it to attach. You hold that wire and twist. So now we're twisting. Now you can see that wire is now attached to that post. So the next thing you do is you want to take a little solder and touch it to the base of that. And now that component is wired up. So that's how you wire up a particular component. And you just do that based on your schematic until you get them all done. And once you get them all done, you can flip it over and start checking all of your components to make sure they're all in the right places and you're getting the right results. So this little tool, along with this stripper, will provide you an easy way to mount all of these components. By the way, it goes right inside here like this so you don't lose it. I used to buy these at Radio Shack, but you can still get them on eBay. And it's a very easy way. And of course, then make sure you order these little holders. They come in like 100 of them in a pack. I got these from Vector. And very easy to use. Okay, this is the back glass, and you can see if I zoom in a little more detail. What I tried to do here is to show a scene of a city on fire and a bunch of meteors coming down. So when you do your back glass, what you want to do is to first do a small scale one and then work your way up to a full scale one. And if you have the skill to paint, go ahead and paint your own. Or you can do it in Photoshop and find ways to do it. Then you notice on the right, that's where I have my reels. Up in that dark spot on the left, I have a digital readout up there. So that's how I did the back glass. Okay, now we're inside. Now the wires are hanging down. Those are going to a quick connect here. You can see it right there, and that goes to my flippers. So I can reach down and quickly unplug that and get that out of the way so you can see the rest of this. Okay, so now you're seeing the reel board, which I had no room for, on the played field. And you can see all the connections in my circuit board. I can zoom in a little bit closer on that so you can get a little idea what it looks like. And you can see all those solid state relays on there too, and all those solid connections and terminals that I used to get that reel board complete. Now as I move a little farther down, you'll see my two power supplies, the main ones anyhow. The one on your left is my 48 volt that runs all the large components, and then the one to the right of it, it's got a lot of holes in it. That's my 5 volt power supply that drives all my logics. Now as I move over to my right, you'll see a blue board that has a chip in it, and if I look slightly up above it, you'll see a black box, and that's actually my power supply that drives that. It's a 12 volt power supply, and that drives all my LEDs that run on the cabinet. And that little tiny green one there, that right down there, that green one, that's the little power supply that I use to power all the rest of my LEDs, almost 300 of them. Okay, now starting up here at the very back of it, you'll see right up here I have an infrared circuit that I put on this 1970s style ball return ramp, and I put a optic sensor on there, an infrared one, that lets a chip know that there's a ball at the bottom, and it'll activate that and kick the ball back over into the shooter lane. And now if you look over to the left a little bit, you'll now start seeing some of these solid state relays and see how tight they get in here. I don't have a lot of room. And you can see them on the right side too. And you can see all those terminals I have in there for the various things. This right here is a power supply for the large terminals. Now right here is an odd shaped device, but that's my ball saver. And in those days they used these solenoids, one that way and one that way, to pull it up or let it down. And then if I move a little farther down, you can see one of my flippers with a very, very large coil on it, and you can see how this flips once it closes. It's actually got two coils, a large coil that flips it hard, and then a small coil that holds it open when you want it open. Okay, moving farther down, you can see that is called a slingshot. And there's another one right over there. There's always usually two slingshots on every pinball machine. And then if I move over here a little bit to the left, you'll see some slots here. And these are rollover wires from underneath, and I'm using micro switches on those. So here I am using leaf switches, and over here I'm using micro switches. And if I move farther down, you can see these green solenoids, and you'll see that those are my pop bumpers. I have 3 of them, and they use leaf switches. You can see one in there right there. If I move farther down, you can see targets, and these are targets from underneath. These are stand-up targets using leaf switches. There's another one right there. And then over here I got another rollover wire. Also you can see my kick out hole, and it kicks this way and kicks the ball back out into the play field after it. And I also have an infrared sensor right there that allows it to sense that ball and send it back out. Now this one here, that's a rollover button, and you see I used leaf switches there because they're much more effective for that particular circumstance. Now as I pan back just a little bit, you can see all the terminals I have, and all the ones on the left side over here are for my reels, for scoring. And then the ones on the very far right are my 48, my 3 volt, and my 5 volt terminals running everything else. And if I go a little bit underneath here, you should see all those on that board there, all my quick connects to all my various things that I need to have operation, with all the wires hanging down. And of course right there on there at the bottom I have a voltage surge protector that helps me with that. So that works pretty good. Now I'd like to show you the fronts and backs of how these breadboards that we worked on earlier on. Now this happens to be my largest chip, and it's a 40 by 2 pickaxe chip, and you can see how it's mounted. It's mounted on the bottom of the board with just a little piece of wood, so I can take it off if I want. And then you can see as we move down a little bit on it, you can see that it's the wires, and I use that solid core wire to quick connects, and then from that all the wires that come off of that are blue wires going to all the various components that it's going to interact with. And each one of these boards is pretty much built the same kind of way, just with different functions. That's the ball saver, ball return, and that little one right there is a target switch. That was the first one I did. And if I move over here, you can see other ones, like there's one for the slingshots, and then there's another one right down there for sound. So all these boards are designed for individual components. And what I tried to do with the color coding was that all the red and black wires are my high voltage wires, and then with lots of amps. And then you'll notice that the purple and gray wires, those are primarily my low voltage wires to either LEDs or the Logics. And then the blue wires are all the logic wires coming off of the chip. So if I back away from this, you can get a little idea how crowded it gets. So you can see why I like to turn all my circuit boards on end. Now if you look at the back of the circuit boards, you can see that how we did the back. After we got all the wiring in using that tool I was discussing, all I did was clip off the ends of those posts so they're nice and short, so there won't be any chances of them shorting out. Okay, you notice here is how I mounted the inside of that flipper button. And that's just a simple leaf switch, but it's a specially designed switch for the flipper buttons. And these are the connections between the contacts are gold plated, so I don't ever have to worry about replacing them for an awful long time. Now below that, you'll notice there's a plate down there that I talked about earlier. That's the plate that you buy separately from the legs, and it actually gives you the measurement from the bottom of the cabinet to that first point, and then to the second point to where you're going to drill those holes. And later on I'll show you a little simple jig you can use to drill the holes through that in the correct place. Okay, this is something I wanted to show you too, is that when the plunger is completely separate from the play field, it's mounted to the cabinet, so you need to get it really square. So that cabinet has to be square so that that plunger will fall right in the center of that groove that we just talked about a little while ago. So that's critical. And the way you saw how I was able to get the play field up by having a cut in the groove so I could pull that plunger back and then lift up the play field. This is a picture of the first drawing I did for the play field. So I wanted you to see the kind of detail I did early on, even though it wasn't that accurate. This is a photo of one of the carvings that I initially did, and I showed you a short video how the plastics were attached to it. This is a drawing I did on the whitewood that shows how the flippers and the slingshots are initially drawn. You can see a lot of lines in there, a lot of changes, as I found that things really didn't work that well. Now you can see the entire drawing on the whitewood, and I laid everything out with lots of lines to make sure everything was nice and square. Here you can see a drawing of all the holes that have to be drilled for just one pop bumper, and actually 2 holes are missing there. This shows a nice view of how I attached the whitewood to the A-frame and also the disc with the dowel in it, so you can move it into the various positions to work on various components. Here you can see how I actually glued some stainless steel to the carving. Actually, there's 2 carvings, the large arch and the small arch, and you can see how I used very heavy duty clips to hold it in place with epoxy. Here's another example of a wood carving with the stainless covering the arch on the other side of the play field, and you can see how I use those little nylon spacers so I can get the right height Here you can see a photo of the entire whitewood with inserts put in so you can see how the design is taking shape. Now this is one of the slingshots, and you can see a lot of changes in there where I'm trying to decide what the shape should be to get the best possible action on the pinball. You can see how I filled in the holes there with wood dowels. This is a picture of the ball return. You can see how I had to kind of figure out how to cut a notch in there to allow the actual ramp to go underneath the whitewood. And see, this is where you want to figure it out here so that when you have your final play field you don't have to guess on any of this. This is a close-up of the pop bumpers, and you can see how I made the spacing on them initially, and how I also had the rubbers on some of the posts to see how the action is going. And notice at the top there where I don't have that component yet, I have some tape over that large hole with a kick-out hole. Here's the very first board that I did, a very simple board for a target. You notice that there is a small LED there. Also, they let me know that there's power when it's hooked up. Also, there's a jack at the top, and that's a 20 by 2 pickaxe chip in there. Here's another photo of the play field a little closer, showing you how I lit up the LED without LEDs from underneath the whitewood, just to get an idea how I'm doing as far as getting the color arrangements that I might put on the final play field. Here you can see one of the LEDs I used. You can see that they're round and they have a little a rim on the bottom, which is great for mounting them into the Lexan when you're doing the back glass. Now here's where I shaved them down using a Dremel so that I can place them inside the plastic post. You can see they're very narrow now. And there's an example how little space there is between the plastic post and the LED, but that's the reason why I shaved them down. Now this was an experiment to see if those lights would really look cool, and I think they do. So that's what I did in the final play field. This is an example how I'm working out the scoring for the play field. And I think it's good to just draw it on paper and kind of figure out the relationships to various things to see how you want to do the scoring. This is the actual finished play field where I'm starting to lay out holes. And you can see now I've started the initial holes for the post. Here's the plunge router, and you can see that I am making lots of holes. I haven't finished the inserts yet. You can see the center holes haven't been drilled out. In the far left, about in the center, you can see where I had a patch a hole that was put in the wrong place with a Forstner bit, and I'll have to redo that hole. This is pretty much the finished play field drilled out. Almost all the slots and all the holes. You can see the rims so that the inserts can fit into those slots, and lots of room for the LEDs that come up and light up those inserts. Here's a little more detailed drawing showing you how the pop bumpers, the kick out holes, some targets up there in the left corner, and also some rollover buttons, the very large holes. Here you can see the final play field where the inserts are already glued in now, and you can also see the rollover buttons. And I also have the ball return hooked up with some of the support pieces. This is another photo of the final play field with all the inserts in. You get a really good idea of the work that goes into just getting to the final play field, and that's the way it's going to look. And I have to mask all those inserts, plug all those holes, so that I now can do the painting and graphics on it. This is an example on the back box of how I did the speakers for it. And you can see also the slots I put in there on that left side for the back glass to slide into the back box. This shows how you have to cut holes on either side of the cabinet so you can put your flipper buttons in. on the back side, you have to do that so that the nuts will fit flush and the playfield can fit down into the cabinet. This is a photo of the blocks of wood that I did that were used simply, and see the relief there so I can get the drill in, and the lines on there so I can line them up. This is the little jig I used to drill the holes for the legs. This, you can see how I'm doing it. I'm following that line and using the one part of the jig to hold the other taller jig in place to drill the first hole. Then I'll reverse it to do the lower hole. And now the legs will be in the proper position and the holes will be drilled exactly the way they should be. This is the finished cabinet with the back box. Here you can see some of the wiring underneath, and you also could have seen that in the video too, but shows how I'm doing the wiring and then flipping back and forth to check to see if it's right. Here you can see how I'm starting to lay in the paint where all the holes are plugged so that I can get the base coat on, so I can now start doing the graphics on the playfield. You can also see how I'm doing the rails and some of the back supports, and I've covered those back supports with tape because they're stainless steel already glued to it. This is a close-up showing you how I practiced to see how I needed to put the inserts in with the epoxy. Remember that the inserts on the final playfield need to be slightly raised so you can sand them down flush with the playfield. You don't do that on your whitewood. This is the initial wiring that I did on the whitewood, and we changed that quite a bit by doing parallel wiring and cut down on the wiring, which shows you how much wiring there was, and I wasn't even half done. This shows you the actual finished playfield with all the graphics on it, and you can see that the water slide paper was used to do circles around all the inserts, the slots, and also the numbering. Here's some examples of the water slide paper I used to do that with, and you can see once I got one circle I could reproduce a lot of them and use those to go around the inserts and make them look a lot smoother. Here's a photo of the flipper button protectors that I cut out. You can do anything you want, and also notice how I did a little aluminum. This is the actual numbering that I use for the final playfield with water slide paper. This is the largest board that I did. This board is actually the bonus board. Without that large chip is not in there yet, because you never work on your boards with a chip on there. You put the chip in only when you're ready to fire it up. Here's how I mounted my reels. You can see that all the wiring is actually behind it. They take up a lot of space if you decide to use reels. Above that little area there, you can barely see the power supplies above that. So that's how I used the shelving so that I could power up everything while I was testing. And also I used the digital counter for the ball counter. This shows some of the initial wiring that I did for the LEDs, and I did that in parallel wiring, which cut way down in the wiring, about 1/10 of wiring, because I'm doing it in parallel. This shows the rubbers that I placed on, and you can start seeing some of the plastics in the back where I'm starting to make templates. This is a super bright LED that I use underneath the slingshots, and I wanted to use that for the strobing effect. Here's all the lights are on here. You can see how all the LED lights are lighting up. It's before I've got all the plastics completely on. These are just the templates on there now. This is the bonus board all hooked up and ready to be tested. Here are examples of the plastic templates and how I was testing to make sure they're just perfect before I make them out of Lexan. This is the totally finished playfield with all the plastics in place, and you can see how I use the water slide paper to do all the graphics on the play field and also on the plastics. Now I wanted to show you the layout of how I set up my workstation for the whitewood. On the top on left you can see the 48-volt power supply, and then to the right of that is my 5-volt power supply. And down below it you can see I have a 3-volt power supply. And then of course to the right of that you can see my reels that will eventually go into the back box, and also the counter for the ball counter. And then all the wiring is hung by rubber bands down to the whitewood to terminals, and that way I can rotate it back and forth. And at the very bottom down there you can see the reel board. It takes up a lot of room, so I put it on the bottom shelf. This shows you my first initial sketch of how the painting was going to be for the back glass. And this shows you the final drawing or painting of what I eventually put into the back glass. I had it done by a printer and then expanded so it would fit on the back glass. Okay, there you have it. There's the video on some of the things that you'll encounter when building a pinball machine from scratch. I tried to show you some of the things that I ran into and had to solve myself, because you're not going to find explanations on the internet. So we've covered all the bases from the ideas to drafting it, to doing the whitewood, to doing some of the wiring, how to do some of the plastics, and also how to do some of the graphics, and ultimately some jigs to show you how to do some of the work. And hopefully you are able to use some of this information I provided for you and make a pinball machine as good as this one, or even better. Just remember, there's lots of trial and error. Do not be discouraged by things that don't work. That's what the whitewood is for. You make changes, you try to work with your ideas to make things work, and keep adjusting things until they work the way you want them to work. So good luck with your project. I hope that you have much success, and thanks for watching the video.